Zulaikha?
Yes, Dr. Salih, I can see it.
All right. And now that the participants have introduced themselves, now we start the technical content. And Zulaikha, now this we couldn't do at the moment. And after that, now we start the introduction to tidyverse by Zulaikha. Zulaikha, you have to be doing it quickly. Thank you.
Okay. Thank you so much, Dr. Salih. The introduction to tidyverse. Could you in today's world, data science is a buzzword. And how to do data science? We can see that here's a cycle. First, we form the hypothesis, and then we design an experiment, and the collection of data is made on that design that we have made, and on that collected data, we explore it and we apply tests if needed, and then communicate the results. And after communicating the results, if needed, we form another hypothesis and the cycle begins again. So, what is the tidyverse? Tidyverse is a powerful and a popular collection of data science tools within R. Okay, so Dr. Saleha has attended a course master the tidyverse in Vancouver uh, when she was an educational ambassador from Pakistan. So the instructor over there was Garrett Groliman. He is a principal data science educator at our studio in USA. So let us begin. What are the different packages of tidyverse? Tidyverse is a collection of modern R packages that share common philosophies, embed best practices, and are designed to work together. Here are the different packages that are embedded in Tidyverse: dplyr, ggplot2, readr, tibble, tidyr, and purl. Today we are going to learn about the package tidyr. Our today's title of the workshop is Tidyverse, Tidyr, Efficient Data Tidiness. Now, I would request Dr. Salha to please begin forward with the technical
Okay, thank you very
definition
much.
of the tidy data.
Thank you very much for that. Thank you. All right, ladies and gentlemen, the next thing is, what is tidy data? Because the first thing is that we keep on saying tidy, tidy. We need to understand what is meant by this term. And after that, I'll talk about those two functions, gather and spread. So, ladies and gentlemen, a data set is tidy if and only if each variable is in its own column. As you can see here, the variables are country, year, cases. Now these are the cases of some particular disease, for example, TB or any disease. So these are the figures for Afghanistan, Brazil, and China for the years 1999 and 2000. So obviously you will agree that the variables are country, year, number of cases, and the population. So the data set is tidy if and only if each variable is in its own column, each case is in its own row. Please do not mix up this word case with that word cases which is up there. This is just a coincidence that over there also we have the word cases. But there we are talking about medical disease cases. Here we are saying that each, what can we say, each observation, each, for example, if there are people, each individual is a separate case. The observations taken on any particular individual is a separate case. So here the word case is a technical term in this manner. Going back to my point, that tidiness is defined like this, that if each variable occurs in a column and each case occurs in a row and each value is in its own cell, which naturally it will be if it is like this, it will be like in its own cell. What is non-tidy data? Consider this example. We have three lists here. List also is a technical term in tidyverse. So the first list contains these cities, and the second one contains the size of the particle, the pollution that is happening. Either they are large size particles or they are small size particles. And the third list gives you the amount of those particles. And then we can have these 1, 2, 3, 4, 5, 6 as the serial number or whatever. But you see, this is not easy. I mean, how do I put these together? And then 23. Okay. So the first case is that in New York there is large size pollution is this much. Then another one, New York, small size pollution 14. Just note, ladies and gentlemen, that there are 3 here in the first row, but in this list there are 4 here in the first row, because it just comes down, and so it's quite difficult. I mean, if I have to match this London here with the size of the particle, I don't have to go here, I have to go here. See, London is the 4th one here and small is the 4th one here. So if I went like this straight, it would be wrong. So I don't need to do more than this. I think you've got the point. This is not tidy data. It's not easy, it's cumbersome. Now let us look at an example. I will present to you a data set that demonstrates multiple ways to lay out the same data. A segment of data on the number of TB cases documented by the World Health Organization in Afghanistan, Brazil, and China between 1999 and 2000. Now I'm going to present to you 5 different formats. And if we type TABLE1, we get the first format. TABLE2, we get the second one. Those of you who have their laptops open, please do not unmute your mic, but maybe you can try typing it and maybe you can see it. So now, if you don't have the laptop, it's fine. Just follow what's happening, and later you will be sent the recording also. So then when you can actually open your laptop, then you can try all these things out. All right, so the first format, table 1. This is the tidy format, right? Country, the variables country, year, cases, population. They are in their own columns, and those cases are in their own rows. This is being depicted here. Now the format number 2, if I type TABLE2, this is what I get. Now, why am I saying that this one is non-tidy? Why am I saying that? The first one, country, is fine. That is in its own column, that variable. The second one, year, is also fine. But now just look what's happening now. If I want to talk about cases, I have to look at the 4th column in the first row and the 3rd row and the 5th one, not the 2nd, not the 4th. And then also if I want to look at the entire population, then I have to look at the 2nd value in the 4th row and the 4th value and the 6th. So this is quite cumbersome. Is it or is it not? Of course it is. So then format number 3. Now this is also, and you know, this one has been derived from format number 1. The first table, remember, country, year, cases, and population. Now you simply divide the number of cases of any particular row with the number of, the population of that particular same year and same country. So you get the prevalence rate for that particular disease. And again, the same thing is happening, that every variable is in its own column. Format number 4, if you type TABLE4A, you get this first contingency table. And if you type TABLE4B, you get the second one. This one is a contingency table, which many of us are used to all the time. And it's not bad at all. Of course, for some purposes, it is very good. But you know, according to the technical definition of tidy, this one is not tidy. Why? I will explain later. If you first look at the format 5, that's the last one that we have, this is again tidy. And this one is very interesting. You remember previously we had 1999 written together, 2000 written together. Here the century has been bifurcated from the year. You know, they have been separated. So this is the century, 1900 and something. And this is the 99th year of that particular century. But you see, again, it is in the tidy format because this variable, this variable, this variable, and this one, they're all according, I mean, in columns, as it should be. So going back to format number 1, tidy data, this thing that I was saying that, you could get the rate of that, first look at this thing down here. You see, if I type TABLE1 $ country in my tidyverse, if I type this, then only column 1 will be exhibited. If I want to see only column 1 country, then I should type this thing. Similarly, if I want to see year, then I can do this. Similarly, this one. Also, I want to show how you got that other column, which was called rate. This is the code that you would apply. TABLE1 $ cases divided by TABLE1 $ population. And then you put an arrow and you write TABLE1 $ rate. I mean that you want to give it, the name rate. You want to give it the name rate. So then you write this TABLE1 $ rate, and you will get that table in which you were able to see the rate. You will get that column entitled rate. So this is the code. Now, see, this is also being exhibited here. I can show it again. That if you do this code, then you get this new column. All right, now, ladies and gentlemen, it has been said that tidy data, and you have seen it, tidy data sets are all alike. But every messy data set is messy in its own way. Also, it has been said that data comes in many formats, but R prefers just one, and that is tidy data, the format that I've explained to you. All right, this was the end of the first topic, the definition and the concept of tidy data. Ladies and gentlemen, let us now focus on this package called tidyr, embedded in tidyverse. And what is this? Ladies and gentlemen, this is a package that reshapes the layout of the tabular data. In other words, you can tidy up your data with this tidyr. So first command is gather. So let us consider a toy data set named cases, created by which, this is one we create ourselves using the function tribble. Now, the ones who are joining for the first time, please, you have to be patient. We did this last time, doesn't matter, just accept it, just accept it. Like, when we say that we want to open the light, we just have to press that button. We don't have to be electrical engineers to do that. So at this point in time, just accept it as the proper function for creating this toy data set. And this one we are going to create in a contingency table form. So you see, this is the code. We give it the name of the data set is cases. We can give any name, but suppose we want to give this name. And then we put this arrow, and then we put this, we type this, TRIBBLE. Then we open the parenthesis. Then we put the tilde sign and we type this word country. We put the comma. We put all this. All this we have to type. We have to type all this thing. This is a toy data set, just a small data set that we can create ourselves in tidyverse. And please don't forget that after all this, you have to close the parenthesis also. So as soon as you do that, ladies and gentlemen, you get this output, data set entitled cases, and it is in a contingency table form, as you can see. On this side, you have the countries, and on this side, you have the years. And inside the cells, you have the number of cases of that particular disease, whatever you might think it is. Now, let us examine this data set. Let us look at it in a slightly different way. What are the variables in this data set? The first one is already highlighted, country, France, Denmark, USA, I think this can be. So we've written here, country, the first variable, country. But then we have another one, right? The year, 2011, 12, 13. So obviously that's the second variable. But ladies and gentlemen, when we look at in our classes, at least in Pakistan, I think we do it. When we look at these cells inside all these cells, we say that these are the values, and we don't think that these are variables. But see what Garrett taught me when I was in Vancouver. He said that this is the third variable. It's the count. You see, after all, the count is also varying. Is it or is it not? Of course, there are different values. So this can also be regarded as a variable. All right. If this is so, then now let's look at this question. How would this cases data set look if it had the same values grouped into 3 columns, meaning that those variables, country, year, and count. Now, instead of count, we are wanting to call it N, number of cases. But meaning that, just see what I have underlined, that we don't want it in that previous format when, you know, it is round things and all that. We want them to be in columns. So what do we do? What would it be? Just have a look. It's very interesting. This is our contingency table. I want these all 3 variables, the countries, the years, and the count, the number of cases. I want them in columns. So if I were to do it manually, if I were to do it on a piece of paper, what would I do? This first L-shaped thing becomes the first row. The second L-shaped thing becomes the second row. Third one, fourth one, fifth one, sixth one, seventh, 8th, and 9th. And this, ladies and gentlemen, the one on the right side, is it or is it not tidy data according to the technical definition that I have presented to you? The question, yeah, this is also for depicting that. All these variables are in their own columns. And the question is that, it's the same thing. Of course, it is eligible to be called, that's what I think, tidy data. So then how do we achieve this? Of course, we are not doing it manually. We want to do it by applying some command. So the command is gather. So this on the left side is our contingency table. We simply have to apply the command gather, just this one little word, and we get this tidy format. And just be very attentive to what I have to say now. Ladies and gentlemen, please note that the first variable country is already in a column form. Please note that. Here, FRDE US repeats 3 times. This, this whole thing repeats first, then again, then again. But the point is that it's already in column form. Now, this variable is in this row direction, and this third variable is in all over here. So we want this one to come here, and this round thing to come here. These numbers have not been put by me. They were put by Garrett, who taught over there. So now just see what's happening. What will I do when I actually have to do it myself? I will, in the code which is coming up in the next slide, this thing which was in the row here, I will give it a name myself. I'm writing this name myself. See here, we don't see anything like that. We do see country for these, but we don't see year written anywhere. So here I'm writing it myself. But these 3 numbers, 11, 12, 13. So in the command that is coming up inside the gather command, we are going to do this. So this is the key that these columns, you see, this is also a column in our contingency table. The second column of our contingency table, this third column, the fourth column. So former column names are now going to be put here. They will be coming here actually, and here we are writing here. After that, this other one also. The former cells, these values in the cells, they are coming here. And this name, I've given it myself. All right, so by doing this, we got it. So now let me actually give you the code. Now this is the toy data. This slide has been repeated. And this is the table we got. And now to reshape it using this command, this is actually the way you will do it. First of all, you write the name of your data set. Then you apply the pipe operator, which we covered last time. this percentage greater than percentage is called the pipe operator, and it enables you to apply various commands on your data set. So first you write the name of your data set, then your operator pipe, and then you write GATHER, the command that we are discussing here. And then inside the parentheses, this is what you do. The first the one is the year, the second one is N, and then also look here, 2:4. Numeric indices to indicate the columns that you would like to collapse. You see, you had the second and the third and the fourth columns that you wanted to collapse. This is the second column, this is the third column, and this is the fourth column. So you wanted to collapse these values into one column. So that's what we are saying in that next slide. This is in fact all these slides were given to me by Dr. Garrett Grolleman and to all the other participants in that very, very important meeting, the joint statistical meetings of the American Statistical Association, attended by about 7,000 people. All right, so look here again. Alternative way of writing that code. Actually, it's just a shortcut way of writing the previous one. Just look here. I do not have to write E equal. I don't have to write it. I mean, even if you write it, it's fine. Even if you don't write it, simply write here and simply write N. Don't write value, then also it works. But of course, if you write it, then also it works. So here we did not, we just wrote here N and 2 to 4. So see column number 2 of this contingency table, 3 and 4. These slides are basically from Garrett. I simply put these arrows on them. All right. Now this is an alternative version, actually an alternative version. Remember previously we were writing 2 to 4 to indicate which columns we are going to take. Now we are writing the titles, 2011, the name of that column, 2012 and 2013. All right, this also works to get the same result. Now there's another version also, another alternative. Just look here, minus country. You see that first one, I was saying to you that that is already in the column form. So please do not gather that. Don't gather that one. So gather everything except country. All right. So this is not country. This one is not country. This one is not country. So just do it. So this also works, ladies and gentlemen, and it gives you the result. Now reverting back to table 4A derived from the data set 2. Remember I showed you 2 contingency tables. Now if I want to use gather to reorganize table 4A into 3 columns, country, year, and cases, then I will, it's almost the same as the previous, but you see in the previous one we had Denmark and something, USA, etc. Otherwise it's almost the same thing. So this is Afghanistan, Brazil, and China. So I will want to use the command gather to reorganize my table. So what do? I write the name of my data set. Please note here the name of the data set is TABLE4A. And then I apply the pipe operator. And then I can write it here in the first row, or I can enter. And many times people enter, but it really doesn't matter. You can write it in front also. So you have to write GATHER. Then you open your parentheses, you close your parentheses, and you can use any method. I'm using the first one here, the name of this second column, because I want, sorry, this is the output, sorry. Here, these, remember the here was in the row direction. So I'm giving it the name here, and then I'm writing that there. And after the comma, I'm writing those which are the values, you know, previously all these values here, but now they are going to come in that third column. And the name again, I've given it myself. All right, so this is the code and this is the output. So some of you are fast. If you have been able to access table 4A, but just by typing table 4A, if it is there, then you can write this code just now and maybe you can get your data in this format. All right, after that, we have the alternative one. It's almost the same as before, except that it's also written here, convert equal true. But actually in both ways, even if I was not writing, it's happening. And even if I'm writing, it's happening. So after this, the last one that I have to discuss with you is spread. Just two commands I've taught you, gather and spread. I mean, I'm trying to share with you. So what is spread? Spread is kind of the opposite of gather, all right? The opposite of gather. So let us consider another data set called pollution, created again by using the function tribble. This time we are creating it not as a contingency table, but as a tidy data set. So this is the code. You give the name, whatever name you want to write. Even if I misspell it, I don't write double L, it will be fine. Whatever name you want to give it, you give it. All right. Then you put the arrow and then you put the tribble, you write it, then you open your parentheses. You see, we have done this last time. So I'm not going to explain it, this one in detail right now. Anybody who's wanting us to send to you the recording of that particular little piece, we can do that for you. So now tilde, we will type city and all this, we will type, and then we close the parentheses and we get this output. Ladies and gentlemen, this is not a contingency table. This is that tidy format. Remember? If I look at this, what are the variables in this data set called pollution? The first one is in the tidy manner, but then what about the next one? If I want to find the large particle size, I have to go to the first and the third, and I mean the amount for the large particle size, the first, third, and fifth. If I want to look at the amount of the small particle pollution, then I have to go to the second. So even this is, if you look at it like this, then even this tidy one is kind of cumbersome. Isn't that interesting? So by this time, you should have realized that tidy data is actually a technical term. Because you see, if we were to fight with each other on just this issue that, I say that is the good one and you say this is the good one, we can say that even this is not good. So it's not, that tidy means actual something clean. It is the technical definition that this one is actually tidy data. So now if I want this to become a contingency table, which is easier for my human brain to work with, maybe the mechanical, electrical, electronic brain works with tidy format, but my brain wants to work with the contingency table format, then what should I do? Then, hello? Then I will, please, if you would mute your mic, Iftikhar Sahab, I'll be grateful. Thank you. All right. So now, ladies and gentlemen, this is the tidy one. Each variable in its own row, each case in its own column. I've said the opposite of what I should have said. I'm sorry, because of that muting, unmuting business, which is fine. I say it again, each variable in its own column, all right? And each case in its own row. Now, if I want to create a contingency table so that for my human brain it is easy, then of course I will, if I do it on a paper with my pencil, then this is what I'll do. This is what I'll do. This is what we do. This is to be done and this. When we do it manually, this is what we will actually do. But now, if we want to do it through TIDYVERSE, all I have to do is to write SPREAD and the parentheses, and we'll get it. All right, so again, it's, as I said, it's the opposite of what was happening previously. And now you see this first one. So large, small, large, small, large, small. So we put it here. I mean, when we type spread, it puts it here in the horizontal direction. And then the amount, all these figures, it puts it inside here. All right, so then again, this is Garrett telling us what is being done. Since time is much beyond what we had thought, I have to hurry this one up. The code is, we type the name of our data set, ladies and gentlemen. I will not hurry this up. This is what we are teaching you. Then we put the pipe operator, after which we can put whatever we want to do. So we want to do the spreading business. So I write SPREAD. Then of course I will open the parentheses and I will close the parentheses. And inside I write size. Oops, sorry. Previously, this was the name, okay? This was available. I had written it, I had typed it. Now in my output, it's not there, but in my input, it was. So for the spread command, I have to write it. And then what the other thing I write? Amount. Amount was also written there. It was there. But now in the output, we don't see this word. But since we are moving from here to there, so of course I have to write these two words. And then it gives me this format in which these two words are not there. But it is all right. We know what we're talking about. All right. So again, it's just about the same thing. Previously, we were writing these two words, key equal, value equal. Now we are not writing them. Even then we get it. There seems to be a slight, does it? Dr. Sharqa, please, if I'm wrong, then tell me. I think here we are not putting those inverted commas, but maybe it is all right here. Can you unmute and tell me for this one? Dr. Sharqa, are you there?
Yes, there should be inverted commas.
There should be, I think,
Around
yeah.
the size and
I think they should. All those people who are here for the third time, you're already experts and you know it better than us. So you please try both ways. Either put those inverted commas or don't put them. And you know, when my students in my college, when they are kind of you know, worried what's going to happen, I say, my dear student, my dear child, nothing is going to happen. The maximum that will happen is that it will say error. Nothing else is going to happen. It will simply get an error. So you can play with it. You can play with it. You can try it out. All right. So this is by applying this code, we got it. Okay. All right. Now, if we go back to that who data and we want to recognize this one, then again, we do the same kind of stuff, same thing, and we get the thing. Dr. Sharqa, Hashmi, I think you would like to share your own slides now. Hello.
Okay.
But we are having a slight
inshallah.
problem we are having a slight problem, but anyway, let's hope for the best. The voice is not that as good as it was maybe last time, but let's hope for the best. Please begin. Ladies and gentlemen, before she actually begins.
Thank you so much, Dr. Saleha.
Okay, please begin. All right.
Okay. I'm trying both ways, that with inverted commas, the results are same. And without inverted commas, you can see in the console that both results are there. Size without inverted
Dr.
commas,
Sharqa,
size
Dr.
with
Sharqa,
inverted commas.
Dr. Sharqa, I have to interrupt you. You need to put that red thing because some people are here for the very first time and they don't know where you're going. So we need to see your cursor. So make that red pointer, please make the red pointer visible.
Okay.
Because some people have never ever done this before. Hello, Dr. Sharqa. Is there a problem? Dr. Sharqa, I can't hear you. I think there is a connection problem. Dr. Wasim, maybe you can mute your mic and call her to find out what's happening.
Yes, I'm calling her. I'm calling her.
Yes, yes. Okay. Now I think I need to share my screen again. Ladies and gentlemen, until this problem is over. Yes, are you back? Okay. Yes.
My computer shut down by some problem. I'm continuing with your slide set, please.
Okay, all right, all right, all right. Thank you. I will try to be with you as you go on. But now there's another problem. You see, many times this gets stuck. I have to stop the share, I have to escape that thing, and then again start it, and then it doesn't get stuck. I'm escaping it now. I'm sharing the screen again. If it doesn't work with the slideshow, then I will work with it in this mode. Ladies and gentlemen, Miss Dr. Wasim, can you see the slides even though
Yes,
they are not on
yes, your slides are
slideshow?
visible.
All right, all right. I
Please
will
start the slideshow.
I will try it once more time, the slideshow. It worked when I was talking, but just now it got stuck. So a slideshow from the current slide. Okay, go ahead, Dr. Sharqa, please.
Thank you so much. Who is the file which is a data frame taken from the World Health Organization on the TB data set, in which TB data is taken from 1980 to 2013 data is collected, and in 2014 data is collected, so up to 2013 data is present in this file. This file consists of basically few variables. We can view this file using this command VIEW. V should be capital, and within parentheses we have to write the file name who in the small letter because it is defined in the small letters. So by this command we can view our file in the our environment, and this is the slide you can see. This is the file in which first one is the variable country. Next is the ISO 2 and ISO 3 are the country codes related to the two letters abbreviation of the countries and three letters abbreviation of the countries. So these two are the country codes. Next is the year, and remaining 55 columns, one of them is displaying here, new. Dr. Saleha, please go to the next slide. Yes. The next variable is new underscore SP underscore M014. There are 55 columns of such type of variables, in which news means these are the new cases appending every year in the country. SP is the type of the TB, pulmonary disease or something like that. And then after underscore, M stands for male and female. And then 014 shows that 0 to 14 data is the age group 0 to 14. So such type of 55 columns are in the WHO. So total you can view from this file, there are all these variables in the column form, like contingency table you have done right now. This data format is in the contingency. We will convert it into the tidy form. You can see this is the arrow which shows that all columns should be in the row form, so that each record can be written in the row form. So my computer is dying.
Column form, I think you mean.
No,
Okay.
column 2 converted into the row form, like contingency table. You converted all the years 2011, 2012 and 2013. You have done these three columns and wrote in the single column, but all records are in the rows form. So arrows shows that all columns are now written in the rows form. So it will make it in the tidy form. So come to the next slide.
Okay, one moment. I think we need to change the color because some material is in white here. Sorry, one second.
Dr. Saleha, would you please continue with the ggplot with Zulaikha? I'm just switching on my computer because it's ready, going to be ready. Or just wait for a few seconds, if possible.
I think we must not mix up things, otherwise it will become a bit confusing. But let me just get back to the slideshow. So now as she's opening her computer, we would like to gather the 5th through 60th columns of this data set WHO into a pair of key value columns. Okay, a pair of key value columns named codes and N. So then we select only these 4 columns: country, year, codes, and N. So gather, I have already discussed with you, and this is the code, the data set who, then the pipe operator, then the command gather, open the parenthesis. This is the new name that we have given. This is the new name, and 5 through 60, because it's a huge data set, but there are so many different columns. So now we are gathering them. Then we apply the pipe operator again after having done all this operation. Then the next pipe operator enables us to do this next operation on this previous thing, this has already been accomplished. Then the next pipe operator enables us to do further. So now this next operator says that we select something that we covered in the first workshop. We want to select only all the variables other than the columns ISO 2 and ISO 3. We select all the columns other than these. Minus means don't select this one, okay? So we get these: country, year, codes, and N. I show you again. Previously it was country, year. This ISO 2 and 3 we don't want to select. You remember we wrote minus. So country, year. The codes which were going in that direction, now they are in the vertical direction. And all these values inside, because it's a huge data set, you can see there are so many NAs also. And after that, we have the actual numbers. So they were then.
Okay, Dr. Saleha, please.
Okay, I will just
Stop your
do
stop
it.
your screen.
Yes, I'll do it. Okay. So this is what we did. Okay, Dr. Sharqa, about now you'll do it on your art studio, right? And I will.
This
okay.
is
Should I?
studio.
Okay, one moment. I have to escape this. Just 1 second, please. I need to unshare the screen now. Now, please share the screen, Dr. Sharqa. Please share your screen now.
I shared. Can you listen me?
But we can't see your screen. We cannot see your screen, Dr. Sharqa.
Okay.
So maybe you can just continue with the slides for the moment.
No, I think now I'm start sharing.
Okay. Now we can see. Now we can see. It's okay. Yes, we can see it now. All right.
This is our studio, in which you can see there are 4 different sections, in which first one top left is our studio, in which we can write our code, and the bottom having the console. This is the area in which commands are running, and other is the global environment, in which we can import and export data
I think her signal is not good today. Unfortunately, I cannot hear her voice. Dr. Wasim, can you hear her voice? Dr. Wasim?
No, I am also not hearing.
Yes. Dr. Sharqa, can you call her and let her know that she needs to stop the share?
Yes, I made it.
Or can you, as a host, stop the sharing of the screen?
Yes, I right.
You can stop the sharing of her screen, because unfortunately today we are having this problem. I will share the screen again because I need to go on with this. So we have to cope with these things, everybody in this group, I think, knows that some things are beyond your control. So I will now do the slideshow again. And so we apply that gather command again, and that gets this thing into this tidy format. And we select only these 4 columns. We did not select those 2 which were there, which I showed you, ISO 2 and ISO 3. After that, this one, as he was explaining, new is a separate piece of information, SP is a separate piece of information, M014 is a separate piece of information actually. So now we want to, sorry for this problem, actually we changed the color background and we changed the color, but for some it was missed. So I apologize for that. Slideshow again. So for this purpose, that I'll do this again for you, you can then see. These 3 pieces of information which are put together here, if we want to separate them, then what do? Remember, we had already arrived to this point that we had gathered to get the data into tidy format. Then we had selected the variables we wanted to, all variables other than these 2. And then we do this next pipe operator to get to do this too. So SEPARATE, open the parenthesis, close the parenthesis, codes, comma. Why codes? Because you see, this is the name given to that particular variable. That's why. And then into equal. So now we create this vector. For those who are new to R, please note that this thing, you write a small c, you open a parenthesis, you put some things inside. This is called a vector. So this vector has to have these words in it, which we are wanting. You remember those 3 words that I just showed you previously? We want to separate this, so we have to give it a name. We want this as a separate column, so we have to give this a name also. Same here. So that's what we are doing. New is the name we are giving for that first part of it. Type, the type of disease for that middle part. And the sex, age, a name given by Garrett actually. It's basically his slides that we are using. To get that last part where we get to see the sex and the age group of the patient. These names for your data can be any names at all, but for this data, these are the names that we use. And then after that, you see, this is the vector. The vector is only this one, C parenthesis parenthesis. This parenthesis, the outer one, the black one, that is with this command separate. Separate is a function, and the argument of this function is first we have this data set, codes, and then this separation. This variable, I mean, the variable that we want to separate into 3 new variables. And then sep equal from which point you want to separate it. It is that underscore. Remember previously we have this underscore. So this is where we want to break it up. I don't want to break it up at E. I do not want to break it up at after the 0. I want to break it at this underscore. So that's why
I'm sorry,
we
Dr.
write.
Saleha.
Okay, I'll just give it. I'll give it to you. It's all right. Just give me a second.
Okay.
So a column that we wanted to split, this codes, the arrow is slightly on the wrong side. This was remember the column that we wanted to split? This I show you again, codes. And then this is the name of the new column that we are wanting to make ourselves, the 3. And then, sorry, these have to be moved. This is that string where we want to cut it, split it. So this is the code which now Dr. Sharqa will be running on her R Studio, hopefully. And when she does it, what do we get? We do get this. See, we got it. When we apply this code, we get this as a separate column, this as a separate column, and this as a separate column. So here I will, after this, if I want to do splitting of this one also, then I can do the same thing for that also. And now I think, see the locations where you want to split. So now I'm going to stop the share. And Dr. Sharqa, is your, if you can share and we can hear you, that would be good. Please share your screen now.
Okay, okay. Thank you so much, Dr. Saleha. Continuing the session.
And
you
please
see
do,
the,
because of the lack of time now, if you could please just make it a little bit faster.
Okay. This is the who file. We can view this file in writing the code view here and just going to run it, clicking on the run button. Library tidyverse should be done first. Run the library tidyverse first, and then who command will be run. Using the who, we can see the command is running in the console, and the output can be seen in the upper window here. This is the output of the who command, in which countries are present, ISO 2, 3, year, and all codes are, you can see from here, I'm highlighting the codes. These are the codes which shows that ages are 0 to 14, 15 to 24, 25 to 34, and so on. So different codes are from 55 almost columns are there for the different ages and for different types of TB tests. And then we will run this command, in which we are using who, pipe sign, gather, key the codes, and end the observations. And 5 to 60, it means there are almost 55 columns are I'm taking here from contingency table, and then convert it into the next tidy form. And third row, the variable, the syntax is select minus ISO 2, ISO 3, means we don't need to write, we don't need to continue with these two columns anymore. So we are writing here minus ISO 2 and minus ISO 3. I am running this command, and you can see the result is in the bottom, which is the country names along with the years, this one, and the codes. Now you can see the codes are in the row form, and all observations are in the column form. Now it's in tidy form. Original who file is in contingency table, but now after running this gather command and select command, we have file with the 4 variables: country, year, codes, and n. Only 4 variables are there. Now the next command is we can write the codes and without the word key and with the key, both are the same. And next is this command, who, select country, codes, n. This can also be used instead of minus ISO 2, minus ISO 3. The substitute of this one is just mentioning the names of the variables country, year, codes, and n. So this is also give the same results as the above one. You can see the both results are the same. So next command is the separate command. Separate command is this one, in which Dr. Saleha has discussed you, that codes are now splitting into the 3 variables. Now I am running this command, and this command gives you the output like this, in which you can see the country. this one, the country, year, new, type, and sex age. New, type, and sex age, 3 variables are generated by the single variable which was previously with the name codes. You can see codes were converted, splitted into the 3 variables, new, type, and sex age. So whenever you are dealing in your real life, the files which have the codes of the multiple different types of variables embedded in single code, you can split them using the command separate. So the next command is, now we are using minus new. You can see all the variables in the new command having the word new. This command is having the word new all times. So we don't need to write this retain this column in our data file. So we are excluding it by writing select minus new. So I'm running this command. So you can see now the next result is the country, year, type, sex, age, and n. So 3 variables along with the country and n are given, but now new is excluded from the file. Now I'm going to split this sex age. You can see the variable is having male, female along with the age group. So again, separate command is applying on the sex age variable so that we can split it again using the command separate sex age into this one. And now I'm using the separator as 1. It means taking the space of single value. So running this command, you can see the result is this one. Sex is now taking in another separate variable, and ages are now separate variable. Both are now splitted into the 2 variables. Now we can join these 2 variables using the hyphen. By using the unite command, we can combine variables or columns with our own choice. So I'm now using sex and age, 2 variables, and using these 2 variables we can combine and the unite command, using the unite command, and hyphen is embedded in these 2 type of variables. So this command using the hyphen sign we can combine. So this is the result. You can see the result is country, year, type, sex, age, male, and age group are now combined. In between hyphen is introduced. You can introduce anything else, underscore as well. And now I'm using the command same, using the one thing more, which is drop NA. I think drop NA is still discussed by the Zulaikha, but it's a continuation of this command, so I'm running it. You can see that NA having all the variables NA in the red color, not available. So many variables, so many data is in the form of NA. We can exclude those cases, those records from the file by using the drop NA. Within parentheses, I'm mentioning here n from the variable n. So using this command, you can see now the data file is having the values, cases in which n is present. So all the variables, all the cases having the NA in the n variable are now excluded. So this is, I think, the unite and the separate command. Both commands are the complement of each other. Now the next is, I think I must go to the PowerPoint slides, so that up to this one we have done separate, and then unite we have done this.
Dr. Sharqa, I think this
now
is fine. I think this is,
okay.
you've covered all those
Import.
things. So maybe
one thing
yes,
is
okay.
left.
All right. Okay.
Okay. How can
Actually,
we import the data
Doctor,
file?
Okay.
Okay.
All right. Yes,
Okay.
please do. Do.
Okay, we can use our own data files in real life by using import data sets. We save our data files in the form of Excel or in the SPSS form. In Excel, we can save our files in the form of XLX extension or CSV, separated delimited, or in the SPSS form. So both type of data files and as well as the text files and SAS and data files, all files can be imported into the R format, so that we can continue to apply the tidyverse commands on those data files who are initially stored in the Excel files. So I'm now importing a file from the text file, for example, this one. A new window will be opened. Import text data is written here. So one of the participant, Thomas, shared a data file here. So this is import data, text data. Using the browse button, we can click on this and go to the browse to the location in our hard drive. So this is my files, and this is former white PISTAR, in which you can see the extension is Microsoft Excel, separated values file. So this file is now open here. You can see the code is written in the bottom right corner, and in the middle preview of the data is there, and you can just click on this button, import, or just you can copy the whole text from here in the code preview, this one. We can copy this command or either import. We can have this file in our environment. You can see this file is in our environment. This one, x1, date, ch, all these variables. F01, F02, all these are the variables of the file shared by the Thomas. In this file, different rainfall is measured from the part of the Kenya, and group of 3 farmers from each field is taken, and after questioning we can noted the rainfall amount and write down in this file. This is the real data of the Kenya, in which you can see all the dates are here, and the variables F01, F03, or and so on. These are the farmers from different areas are given, and this is the days of the daily data is taken on the daily basis, so time is taken here. But initially it was not like this. It was the farmers, we can it was file like the time is on the column in the column form, and it means dates are there. But after applying the gather command, it's now like this, that the time is date is on the in the row form, so that it's now looking like a tidy form. But initially, whenever it was gathered, it was in the uncleaned form, in contingency form, and after applying the gather, it is not in this form. So you can import your own data sets using the command import, or we can copy this command.
Thank you, Dr. Sharqa. Thank you very much.
We can view. Okay, we can just paste this command here, or we can also paste our command which we have copied from the code writing here. Just Control V and run this command here for the if we want to use in future time. Library, reader, and farmer, all the path is written, and view farmer. By viewing this, we can view the file in our studio. Thank you so much.
Thank you very much, Dr. Sharqa.
Up to Dr. Saleha. Stop sharing.
Okay, so if you would stop sharing your screen, then I would share my screen, and I will ask Zulaikha to Thank
I
you.
did.
Zulaikha, you can just do these 2-3 slides also regarding the missing values. Zulaikha, are you here?
Yes, Dr.
Okay.
Saleha, I can hear you.
Okay, all right. Let me try to do this. Dr. Sharqa has already explained on the in the R studio, but we can also show you the slides, ladies and gentlemen. Yes, Zulaikha.
Okay, there is an other command that you can use to extract the NAs from the cases. That is filter, and in the parentheses the exclamation mark and is dot NA with parentheses. The code written in front of you shows that X is a name of data set, and the pipe command then filter is dot NA and that variable from which you want to extract the NAs. And in the right box you can see there are no NAs in the cases. Only A and D have been shown, but B, C and E are not shown because they contain NAs in contains as values, NAs as values. Okay, alternative approach that Dr. Sharqa have already shared with you, that drop underscore NA for and then the variable name from which you want to drop the NAs. Other example that she has already demonstrated is, sorry.
I don't know, somebody has to mute their mic, please. Please, everybody mute your mic other than Zulaikha and myself. So you were talking about this three, if I can repeat. The first one is filter, exclamation mark, is dot NA. And the second one is drop underscore NA.
NA.
And now, yes, and now please proceed.
This is the example that Dr. Sharqa has already demonstrated. With the drop NA command from the variable N, you can extract the all the variable, all the cases that contain NAs in it by just putting the drop underscore NA. Here's the
Right.
output that you can see.
Right. So, Thomas, you said to me in the WhatsApp communication that I had with you that your data set is very, I think something like unclean, and you said there's a lot of missing values. So NA, I think, stands for not available. So if that value is not available, it's a missing value. So somebody has mute their mic, please. I can hear a little child. Please mute the mic. So I'm saying that if you have a lot of missing values, by this command you can remove them. We are not discussing here imputing values. We are not discussing how you can insert some other values, you know, some good estimates of what might have been. But at least this one thing in today's workshop, we are able to share with you that if you would like to remove those cases which have the NAs in them, then you could do this. Like you see, like Zulaikha just now said, if I apply this command, then that entire row is goes away. You see this entire case, B, NA, this entire case goes away. This next one goes away. This next one goes away. So then you get, what remains with you is that data set in which there is no missing value. So I think that is covered here. And anything else you want to say, Zulaikha, or is this fine?
Yes, it is fine, Dr. Saleha.
Because, all right, thank you. Because now there's no NA in the output. We have only those cases for which everything is available. Now this I had already said to you, ladies and gentlemen, that the ggplot thing we will do only if we have time. And as I was anticipating, once again, we are short of time. So let's just relax for 1 second. And let me show you the plan again. We have covered with you, ladies and gentlemen, up to here only. And now we can, well, also Dr. Alia was not available at that point, so that also is not yet done. So this is not 2:54, it is 3:34 now. So I suggest that we take a break right now. Let's take a little break. We all need to get up from our seats for 5 minutes. And then after that, I have to make a request to people, to my dear colleagues from Kenya, Saudi Arabia, and from Iran, that I can see that it's not possible to, it's our mistake that we felt that we could do it, but I think we can handle only one. So as we do have this break, I will just call you, the three of you, have a private conversation with each one of you, Thomas, Najla, and Raza, and then we'll sort this out. Because after that, we have at 4:10, we need to start the, well, we can cut down this last part also. If you like, we can ignore the verbal feedback, and but this thing still, you know, is the one of the most important things. And so therefore, let's have a break now. I will discuss this matter with the three colleagues of mine, this part, and this part. Thank you very much. I will see you again. We will meet again on this thing. Don't close it. Please keep it open in about 8 minutes. About 8 minutes. Thank you. Hello, Assalamu alaikum. I hope everybody is back from the little break that we had. So I would like to share my screen again, and I would like to say that we are going to continue with the data provided by Mr. Thomas. Let me first of all share the screen. In the plan, as you noted, we are having after this thing, how to import your own data into our studio. Can you, if it is small, maybe I should make it bigger. Let me try to zoom in to make it bigger. All right. Kanwal, if you could unmute and tell me, can you hear me properly? Kanwal, my team member?
Yes, ma'am, I can hear you.
Okay, thank you very much. Thank you. All right. So ladies and gentlemen, who I hope everybody is back. So already Dr. Sharqa has demonstrated how to import data. So she used Mr. Thomas's data and showed you how to import it. Now I will be requesting Thomas to introduce his data and to tell us more about his data, which is to be displayed by Dr. Sharqa, but that's not necessary. If Thomas, you can share it, if you are happy to share your own screen, then of course you can do that. And after that, we will have this discussion on what can be done with this data set. I do want to say to you, ladies and gentlemen, that Dr. Raza, whose name is right here, he has very, very kindly offered to me to do his demonstration next time in the next workshop. So I'm extremely grateful to him for doing this, because obviously otherwise it will be rushed and it is not going to be worthwhile. As far as Dr. Najla is concerned, I've called her 2-3 times, but I think she was having the break she required, so I'm not able to talk to her. I did put a message that is it okay if you can also do it next time? I will just, if she's here, I can ask her. Dr. Najla, are you back? Are you hearing me right now?
Yes,
Okay, we will
yes,
see. Okay, is it all right if you also could do your next time?
yes, yes, it's fine for me.
Okay, thank you very much. I'm so grateful to all of you. Okay, then just I want to say one more time that we will be discussing now Thomas's data in fairly good detail. So it will be quite detailed, but we should look at the time. It is 3:48. And so we must stop at not 4:10, but at about 4:08. 4:08. So we still have a lot of time. I think that's fine. All right, so now I'm going to stop sharing my screen. And Thomas, now you may please begin. Hello?
Hey,
Thomas,
I can.
all right.
Can you see my screen?
Yes.
Okay. Given the time I have, I'll just explain a bit about where the data is from and what it's holding, and something a bit more also about how the data looks like. There you can see the map of Kenya. This data is from 100 farmers who are from Western Kenya. There is like a spatial dispersion of them, but these are more than 100 dots because we actually were working with around 730 farmers, and we randomly selected 100 of them and empowered them to record rainfall data and put them on books. And they recorded for a period of around slightly more than 1 year. Now, the data, like I said, was recorded in books, but we entered it into ODK. So it's just available in the ODK. One of the biggest strengths it has is that it's daily data and can easily be exported to CSV or Excel format. However, from the way you can see on the screen, it had several challenges. One of them is the way it looked like. It was not tidy at all. When you, on the lower left of my screen, you can see that the days of the month are actually like the column titles. And there is a lot of jargon. on the data. Now, the whole idea is to get it to be clean, whether in wide format, as I've been showed in this screen, or even if it's in long format. And like you already also mentioned, there was a lot of missing data because of this, we had to reject some of the data from the farmers because there was a lot of missing data. And probably for the session, if some analysis can be done, it would be very helpful. I've done a bit of analysis on myself, but probably I can share with you after this one. For now, I think that's all the time I have. Thank you so much. Hello.
Excuse me, Thomas, I want to ask that from left file to right file, which command did you apply over there?
At this
And get the
juncture,
right
when I was preparing it, I did it some time back. I didn't know enough of R, so I just cleaned it in Excel.
But you converted the data format from column values are written now in the row form in the right format in right file. Did you apply any command on that?
No, for cleaning purposes, no. But yes, for analysis, I did some analysis. I can share with you some analysis if you are interested. Let me just give me a minute. Like I mentioned, the data was from farmers. Just a minute, I'm trying to open an image. Yeah, so this is an image I prepared for one of the farmers groups. And from the image where you're seeing gray line.
Thomas, I cannot see that image. Have you shared it on the screen?
Let me try and share it, sorry. Can you see it now?
Yes, yes, we can see it now.
Thank you so much.
Yeah, so this is an image I prepared, which kind of shows like for individual farmers, like the first farmer is farmer F02, that's a code we gave them. When you see a gray bar line, horizontal bar line, it means that data was recorded for that day. There was no missing, whether it was 0, but just not missing, not an NA or 9999. When you see a black spot, like with the F22, that means on those few days, the data was missing. So we could also be able to calculate for the farmers to what extent was the data missing, like available. Like for F02, he had around 95% of the day recorded the data. So there are other analysis we did just to compare their data with the Kisumu rainfall, but I don't think they're for this training right now.
Thomas, if I can ask a question, what I have understood is that the black thing is showing the missing data.
Yes.
But the question is that why is it black on the right side for all of those, whereas on the left side it is not black? Yeah.
Yeah. I actually added an extra month. You'll notice that this is a time. The horizontal axis is a timeline, and I added an extra around 30 days. So just to check that everybody, at least the last person should have been at least 30 days in between. But probably it's not the right thing. I should have stopped it where like the F02 stopped.
So exactly what was the purpose of collecting this data, and what do you want to do with it after you have I mean, now what have you done some analyses with this data?
Yes. Yeah. So the purpose was is particularly for a project first. I didn't collect it just for myself. It was a project, and they were interested to use what we call crop models, but using local data for farmers.
Okay.
So they can use their daily data, put them in a crop model. One common one is called APSIM, Agricultural Production System Simulator.
Okay.
And then they calculate to see how would, for example, maize perform under that climate. Purpose, but I've used it for other things. I've tried to form time series models with it. Yeah, and I've published something on that, which I'm happy to share if you can have a look at it.
You have published something based on this data set that we are seeing right now?
Yeah.
Then it will be nice to see your published work also. If you can share it, that will be nice.
Yeah, I'll share, but then given my time is already up, I can share and then you can share with people over the email.
No, we do have time because both Dr. Raza and Dr. Najla have offered that they will do their data next time in the next workshop.
Oh, okay.
So now you have time.
So what I did with it, I tried to use the time series models. In particular, there is the VAR model, the vector autoregression, to see if I can predict a daily value for a farmer. I'm looking for other papers, sir. Okay. Okay, I did this paper. Sorry, this one I used models for Kisumu rainfall data. Sorry. So the one I did with it, I have not really yet published it, but I have it somewhere. Let me show you. Just give me a minute to open it.
Anybody, any participant would like to give any input in this time, you're welcome to do that. Dr. Amjad, would you like to say something, being from the Pakistan Bureau of Statistics, dealing with huge data sets and also having missing values, while Thomas is getting ready for this? Are you ready, Thomas? Then Dr. Amjad can do it later. You have opened your correct file.
Seconds.
Okay.
A few more seconds. Yeah, I've got another paper. So let me, can you see this screen or should I reshare it again?
No, we can see it. It says spatial, let me read.
Fantastic.
Let me read it for you. Spatial comparison and quality.
Yeah, that
All
one.
right. Please make it big.
So, okay. So this paper was basically looking at farmers' perception about their historical data. The graph you're seeing right now, you can see some excess. I'm hoping it's clear enough. Let me use my cursor. So here, this is a certain year. It's not clear at the bottom, but the farmers will recollect which year did they have extreme seasons in terms of rainfall. So this is above normal, normal, below normal, and the short seasons, and also for the long seasons. In Kenya, we have two seasons, one between March and May, and another one between September and December.
Okay.
So what I did, using the farmers' recollection, this one actually, I compared with the Kisumu data because it was complete. Sorry, there's a problem with my screen. So the first thing I did was try to compare
No problem. Yes.
I kind of tried to compare it with the Kisumu data. Kisumu, when I say Kisumu data, I mean it's data from a meteorological station, which is complete. I will say it has accuracy. And the things I found, I'm not so sure why it's skipping a page. It's kind of skipping a page, and I don't know why. But let me explain the graph you're seeing right now. So in this graph, I did a different thing slightly. I tried to check how different is the farmer's individual data compared to the one from Kisumu. We don't expect them to be the same, but we can check, are they different? And then I used a threshold, the normal threshold, which probably when if you've heard of Dr. Roger Stern, in his work, he's been using a threshold of 0.85 millimeters for a rainy day. So I used half of that. And I said, if the difference between an individual farmer, let's say F01, is within that range, then their data is basically similar. And I called it near data. If the difference, the farmer was experiencing a lot more rainfall, I will call it over data. And if it was a lot less than that, the difference, then I'll call it under data. And this I did on the days that were paired. So if it was 1st January 2014, I compare from 1st January 2014 up to 2015, and I count what was the proportion of days that were having the same amount of data with Kisumu, extra amount of data with compared to Kisumu, and a lot less data compared to Kisumu. So what this graph basically tells us is, as much as the farmers felt that their data was different from Kisumu, half of the time, if you notice, the green bars are basically 50% in most of them. Half of the time, their data was very similar to the Kisumu data. I kind of also worked with other volunteer stations from that region, and they had a similar experience. So basically, we all know the data from the local people will be different from the Kisumu data, but what my analysis was saying is that it's not very different that you can just say it's always different. No, half of it is always the same. The other half is either slightly, a quarter of it is slightly more, a quarter of it is slightly less. But if somebody doesn't have local data, they can easily go to the Kisumu Met station and ask data from there and use it even in the models. That's my big conclusion from this one. I'm hoping I'm coherent enough.
Oh, yes, of course. Thank you very much. Dr. Amjad, I would like to have your input on this whole thing. If you would unmute your mic and please share with us what you think about this whole thing.
Thank you very much, ma'am. Thomas, please, you have collected these data from the farmers, as you told.
Yes. Yes.
Then why don't you go to metallurgical department for the accurate and scientific based data? Because farmers have subjective approach. They cannot give you the exact measurement of the rainfall data.
If I might respond. So this was in collaboration with the meteorological station. So they provided the data. The good thing about the meteorological station, they have a long history of data. And of course, many people show the scientific validity of the farmers' data, but increasingly a lot of research want to be farmer-led, rather farmers to involve a lot more. And so what in this project we did, we empowered them, we trained them how to record, we got some rain gauges for them. The rain gauges were kind of not very strong. That's why eventually after 1.5 years, all of them, they depreciated. But we were together with Kenya Met. Kenya Met is the Kenya Meteorological Department. we were with them in it, and they were also interested to see if farmers can collect data that they might be interested in using in their own grid. As of now, I don't have a chance to tell them you must use it in your grid.
Oh, right.
Yeah.
Then your prediction and forecasting will be fruitful definitely for the farmers that they can plan their crops in coming years and in coming seasons. Then it's scientifically, we can say that you have trained your farmers also to maintain the data on rainfall in your areas.
Yeah, we did train them.
Thank you very much. Thank you.
Okay, thank you
Isha,
very
that's
much.
a very nice question.
Thank you very much, Dr. Amjad, for your very good input. And thank you, Thomas, for this very interesting work that you have done, for sharing it with us. I appreciate it very much indeed. I would now like to request you to please stop sharing your screen, because we now have with us Dr. David Stern, who, of course, Thomas, you know him, I think, very well. And
yes,
because he has been working in Kenya for so many years. So,
yes.
ladies and gentlemen, Dr. David Stern is on the call, and he just now said to me when I asked him that, have you joined? He said, I can hear Thomas speaking, and so he's very much with us now. So now I formally invite Dr. David Stern, who I asked him to, to send to me his CV so that I could read out his CV and I could share with all of you all the excellent things he's been doing. But he did not send to me his CV. He's a good friend. I have known him for a long time. He's a young, energetic young man, and I've been meeting him in these international conferences for the past 5, 6, 7 years. Highly impressed by his excellent work. And as I was speaking, he has already shared this slide. David, you are, I hope I'm saying the right words, you are a member of the ISI Task Force on Capacity Building. If I've missed out any word that should have been in between, please go ahead and correct me. Over to you, David.
Thank you very much. It's a real pleasure and a privilege to be here. I've been kept informed about these wonderful trainings that PISTAR has been doing, and I'm privileged to be able to be here and contribute to one. I think one of the things I'd like to start with my talk is to really sort of say how the way that these trainings have been based around the tidyverse is something which I'm really impressed by, and I think is really a sign of how R itself is maturing. And so really the aim of my talk here is really, I suppose it shouldn't really be seen as my talk. It is a talk about tidyverse itself, and why, which of course the credit for that has to go to Hadley Wickham, and why this is really changing R in fundamental ways, and the way I'm putting it is this is really giving our grammar. And why is that important? Any language without grammar becomes just a series of words, which is hard to learn. Whereas once you put some grammar in, then even if you only come across a new word for the first time, you can know how to work with it. Is it a verb? Is it a noun? Where does it fit in a sentence? How can you use it? The grammar is what helps you to understand these things. Understanding the rules of the language mean that you can use it well and effectively without everything always being totally new. And this is what is being built within the tidyverse, and it's being built very consciously. And I suppose before I delve in to what that means and what that's about, I should say a little bit of where it comes from, because it didn't start with Hadley Wickham. In fact, his PhD was building the grammar of graphics for R. This is where ggplot came from. That was Hadley Wickham's PhD thesis. And, you know, this grammar idea for graphics came from Leyland Wilkinson, you know, quite a long time ago, and he wrote a book about it. And that book was in many ways visionary. And what it recognized, and then he sort of built a software around it, and others built a software too. And then, as I said, Hadley Wickham, as his PhD, implemented this for R in a way which was really impressive. And through implementing it, he changed the grammar, he edited it. And then from there, he has now taken what he learned from that process of building grammar for graphics and applied it across many different aspects to try and understand, how do we work with data? How can we actually put some grammar, some structure to that working with data? And so, in short, what the grammar is doing is it's providing ways of understanding and manipulating data in a way which is consistent, which has a few different actions where if you're doing things which are conceptually similar, then they are associated as being the same, even if what they're doing and what's programmed behind them is very different. And so let me now go to one of the standard sort of visualizations on this. So let me go back to here. And this is if you want the tidyverse. These are packages of the tidyverse. And so what makes this really different in R is the fact that all of these packages are sort of compatible with one another. You know, there's packages related to importing data. There's packages related to tidying data, to transforming data, to visualizing data, to modeling data. And there's packages which relate to programming more broadly, which is sort of creating the scripts around this. And the idea is that all of these packages are intercompatible. So if you want to use ggplot, you can do it using the outputs of tibbles rather than just data frames. And, you know, and these things are perfectly incompatible. And I will go through and explain this a little bit more, but I think the thing which is so different about the tidyverse within R is that actually this set of packages, you know, we found ourselves, you know, using R in different ways, and we were aware of the tidyverse, and we were trying to, you know, use different packages, and we ended up using almost 200 different packages in different ways. And we found there were only about 10 or 15 that we thought were really good, really well written, and all of them were Hadley Wickham's and part of the tidyverse. And that's when we started to appreciate the depth of the importance of this process. And what's really fundamental here is that the packages themselves, each of them is doing one task, and it's trying to be relatively comprehensive on that task. You know, for cats is helping you with categorical variables. Yeah, it's 4 categorical variables, and it's a really important one. Lubridate is helping you with dates. String R is helping you with strings. You know, these are simple things where you need to do things when you have a string variable, when you have a text variable. And there are things which you need to do with factors and categorical variables. And those are the tasks which really are being exposed and dealt with as part of the tidyverse. So, before I jump in one step forward to actually discuss this, I'd just like to say if there's any questions which come up as we go along, please interrupt, and I will try to do my best to sort of integrate that into the presentation. So don't feel you need to wait to the end for questions. So,
yeah.
Yep, carry on.
Yeah, I just wanted to encourage everybody to do what David has said. If there is any query, please just go ahead and ask right now. I suppose it's all right. David, you can continue.
Thank you. So basically at the start of, and this is now from Hadley Wickham's book on sort of data science and how to deal with data, and it's all built around, think about this in terms of the tidyverse, as he's thinking of when we talk about import, we're talking really about those packages. When we talk about tidy, we're talking about the packages above. And so the essence is, how does this work? And why is this grammar so important? So with import and with tidy, the idea is that before you can really think about working with your data, digging into your data, you need to be able to get your data in to R so you can work with it, and you need to then be able to get it into a form where it's ready for analysis. You know, where you've put it into a form which you can work with it in a consistent way, where you're not always going to have to look for something else. The way I like to think of this for myself is that you're not just importing what you need now, you're getting everything that you might need to understand this data together in a nice, tidy format so that you can use it. And this is where tables come in. That if you're not aware of tables, what they are is they're sort of saying that actually in your tables, you might not just have columns of number strings, you might have more complex structures. And so you can have these more complex structures and they can be represented through these tables because your data is connected in those ways. And so actually you can work with more than just a standard flat data frame. And so the tibble is really essential in that process. And that's part of this tidying. By getting your data into the right formats, you've taken out any issues. You've maybe, as Thomas has sort of explained, identified missing values. You've identified the problems. You're aware of what the data is so that you're ready to work with it. And of course, then the next part is once you actually have the data ready and you're ready to work with it, now you try to understand it. And now this transform, visualize, model may seem trivial, and in some ways it's been part of statistics for many, many years as a concept. What I think the TIDYVERSE and Hadley Wickham have done is they've made this cycle more central. They've, you know, a lot of statistics tends to put modeling at the end. It sort of thinks of it almost more linear. You might want to visualize and transform, but the real aim is to get understanding from modeling. And I love an expression which came again from Hadley Wickham, which is that basically that visualizing, and I'm paraphrasing, when you visualize data, you can be surprised, but you can't fundamentally scale. And when you're modeling, you can scale, but you can't fundamentally be surprised. The modeling will tell you what you already know from your visualizations, but it'll confirm it and it'll tell you in more detail about exactly how much. But it's not going to surprise you. You're not going to learn something you didn't know by running a model. You'll just get confirmation that yes, the results you have observed are statistically significant. They have meaning, they have depth, because the amount of data you have is sufficient. And you can do that on data of sort of large scales in different ways, and you can do it with large number of variables and so on. Whereas when you visualize things, you could find things you didn't expect. You could suddenly see, wait a second, I didn't realize I had that in my data. That doesn't make sense. I should go and clean it. I should transform it. I should remove it, or I should do something else. And before I actually do the analysis, because that might affect my analysis, you can find these surprises. You can find there's distinctions in your data which you weren't aware of, and that you really should be taking into account in your modeling to be able to get the best results you can and to be able to get the correct results out.
David, I have a question here. I have a question
Yes.
right here. This word model.
Yes.
I'm sure that, like me, there are others who are not absolutely clear about what this word means. Now, if
Very
I
good.
share my story, if I share with you my own story, when
Yeah.
I was younger, there was no such word here in Pakistan called modeling in the statistic scenario. It was model fitting, model
Yeah.
fitting. So what I understood then was that we are, for example, we are fitting the normal distribution to that kind of histogram, or we are fitting a regression model. And then later it became modeling. That's fine, that's nice. But to this day, I am not absolutely clear what exactly, all that you said just now, what exactly do you have in mind when you utter this word?
Very good. And I think, thank you for that, because I think this is something where you're right, there's a whole other story which could be told about the evolution of sort of modeling as a sort of concept. And one of the things which I think is important is, as you say, when many people started in statistics, the statistics they learned was, if you want your more classical statistics, your traditional statistics, which was very much about taking a distribution and fitting or data related to those distributions in a way using regression, using these standard models. And this is still an important component of modeling. But it's not the only component of modeling. I mean, the stochastic analyses which have come out more, which are sort of a bit younger, but still go back quite a way, are also very important here. And what they have done is they've liberated from some of the restrictions that your traditional modeling had. And so models now could be your simple regression where it's appropriate. They could be a stochastic form of modeling using basically Bayesian statistics, or they could even be sort of, if you had a complex mathematical or physics-based model, they could even be just looking at the data and the error terms on those, so actually fitting the modeling into a much more complicated model in different ways, which would often be done using these same stochastic methods. And so modeling as a concept, what people have found is that your basic premises of statistical modeling are very simple. That what you're trying to do is, and I like to distinguish between mathematical models and statistical models in this. A mathematical model takes a phenomena and tries to explain on average what's happening in that phenomena. And so you could build very complicated models. These could include differential equations and all sorts of other things. And you could be trying to sort of understand what is happening in that phenomena using mathematical expressions, using equations. And then basically, as a mathematician, you can explain the words phenomena like this. But you can't really test until you bring in the statistics. And what statistical modeling does is it says, okay, it's all very well to have this nice conceptual model, but how does it relate to the reality? We've collected data. Our data is imperfect, but it is there. It's what we have. If we fit it into the model, what error terms do we get? We need to understand how different or what the error terms are on the model. And then you try to understand not only the phenomena, but the error terms you get on data related to this phenomena. And that understanding of the error or the variability in nature, that's really what makes a statistical model different. And that's why it's statistical in some sense, because you're interested in the variability, not just on average. And that ability to then understand the variability through a whole model, that's what statistical modeling is. And these could be very simple models. As you said, your traditional linear regression is just a straight line equation. And so mathematically, that's very easy. But they could also be extremely complicated mathematical models where you're still trying to understand the error terms as they go through them, and that's also possible. And so modeling as a discipline, if you want, is now able to be very flexible in terms of the types of models you can explore and you can use. But it's the desire to understand the variability in the data and the variability that's therefore in nature that really makes statistical modeling what it is. And that's where the distributions come in. And so your statistical distributions are then related to certain natural phenomena. And so you would be checking to see, you know, are your errors normally distributed, you know, or maybe with GLMs, you know, you might have, they might not be normally distributed. They might be skew. You might want to use a gamma distribution, or they might be, you might have to use logistic regression because you've only got 2 possible states, and so on. So, you know, within modeling, there's this whole range. And I believe one of the mistakes that has been made in statistics education in the past has been to not to teach what are considered the difficult models early enough. So the idea of teaching GLMs, and I know many students who have gone through undergraduate degrees and aren't really aware that you can do modeling which, if you don't have normally distributed errors.
David, that is absolutely correct. We don't do that. We don't do that at the intro level, and we are not aware of that.
And the thing which is so interesting, so New Zealand is one of the places which are most advanced on this. So in statistics education in New Zealand, what they've done, and people didn't understand this for a while, they said, okay, before we teach about sort of normal linear regression, we should teach people about bootstrapping. And everyone said, bootstrapping? Why do you want to start with bootstrapping? That's a complicated process and so on. But the insight, the deep insight that they had was you can always do bootstrapping, whatever data you've got. You can even do it when your data is normally distributed. It's always valid. And so if you teach people how to do something which always works first, then as you teach them more methods, you're just saying you could still use your bootstrapping, but this is so much more accurate. You're getting so much better results because you know your errors are normally distributed. But you have a tool which you can always use. And so that's been at the heart of New Zealand education system now for quite a while. And they've been revolutionary in the way they've thought about this. It is really, if I point people to think about where statistics education is happening well in the world at the moment, I point them to New Zealand. The group in New Zealand and what they're doing and the way they're thinking this through, they're not getting everything right, but they are miles ahead of anywhere else I know doing this at a national level. And there are individuals doing this well elsewhere. But as a nation...
Hadley Wickham is also from New Zealand, right?
Sorry, who's it? Sorry?
Hadley Wickham.
Hadley Wickham is, so he is now based, he's not originally from New Zealand, I don't believe, but I think he's now based, I believe, in New Zealand, yes. Is he originally from New Zealand? He may well be. He interestingly hasn't been part of that revolution of the New Zealand education curriculum. There's many other big names in statistics education who have. Maxine, you know, Charlene. There's a really good group that came out of there doing that transformation. And so they were very fortunate to have this very strong group of statistics educators who worked across the board on this reform.
David, thank you for this. This was very good about modeling. My concept is a bit clearer now, but I want to now get you back to the grammar of
the grammar. Thank you.
I have just a question, please.
Please, of course.
David, you mentioned here the number of variables.
Yes.
How much we can deal amount of data in this package? Because we have a lot of surveys which has, very large, very big questionnaires, even 20 pages, 40 pages questionnaire, and there are millions and billions of data are available in one survey or census. Can we deal that in one click in this package?
Well, so I'm afraid, of course, tidyverse is not yet one click, but the idea here is very much, if you look at the import and the tidy, that yes, you can be considering all of those variables together. You can be tidying them so that you can be working with them. And this is Hadley's point, actually. If you want to visualize them, if you have lots and lots of variables, well, you don't have many choices. Either you look at maybe 6 or 7 of them together at the very most, and you visualize them, or you transform them and you do something like a principal component analysis to be able to visualize the outputs of that. But you can only look visually. You're very limited on the scale, on the number of variables, on the number of points you can take in because of our human limitations. And just physically how many you can fit on a graph or into a table in a way which is readable and understandable. So when you visualize data, you're very, very limited in terms of the number of variables you can include. And that's one of the reasons that modeling is still so important, because modeling doesn't have those same limitations. And so actually, if you don't think of modeling as the end, but you think of it as part of this iteration, what you can do is you can use the models to identify some of the variables and the visualizations that will give you the most impact. So when you have a lot of variables, modeling can deal with lots of variables. And the challenge there in many ways is then, okay, so how do you then iterate? Because people tend to think that once you've done your modeling, that's the end. Whereas actually, when you have a lot of variables, you're often doing the modeling to say which variables would be interesting to look at together. And then you can visualize them. And so you need to go through, and you might need to transform them once you identify them. You might need to change them, summarize them in a certain way to bring something out which represents what you're interested in, the results you're interested in. But, and you may find that once you do that and you visualize, you'll get some things you didn't expect and you didn't find in your modeling, but there is a reason that the results came out the way they did. And this could be, actually in your modeling, it could be a positive or a negative result that leads to this surprise. And, you know, for example, let's say in the modeling, there was a particular variable which you expected to explain quite a lot of the variability in your data, and it doesn't. Visualizing with respect to that, because you expected it to create understanding and it didn't create understanding, then you should visualize it. Because it might be that that's because of a few special values, or it might be because there's a categorization you haven't taken into account. You need to look for somewhere else in your data, which will help explain why the variability wasn't explained as you expected it to be. And so when you have lots of variables, this modeling step can be critical, both in identifying where there are results, and therefore there are things interesting to look at, but also in identifying when there aren't the results you expected, and therefore you should be identifying it and understanding it as well. So this is why the importance of this cycle is so great. And I think what is so important, if I were to come back to the grammar on this, is that actually if you get out of the details of what we've been taught as to thinking about modeling as being very different when it's linear regression from when it's sort of doing a normality test or doing this, you know, this is sort of how we're taught statistics. We're taught that these are different things. The idea of the grammar is to say, no, they're not different, or they're just doing modeling. There are many, many different ways of doing modeling, but they're, you know, modeling, that's just modeling. And so the information that that's giving, irrespective of which models you're using and how you're using it, and, you know, that's just the modeling component. And the big insight of that is, which is so important. Yeah?
David, just like you explained the word modeling very nicely, I now want you to please explain what is the meaning of the word grammar?
Oh, thank you. Okay, good. So let me dig into grammar, and I will explain this first very briefly, generally, because people know what grammar is from a linguistic perspective, you know, and that's where the idea came from. I will then explain it very briefly and hopefully clearly where this came from for the grammar of graphics. And then I'll explain how Hadley Wickham is really using this difference in this conceptual framework. So in language, grammar is the set of rules which enables you to understand how people are communicating. So if I take a sentence and I break it down and I understand what's the verb, what's the noun, and you know what's an adjective, you know, those are all aspects of the grammar. And the verb is sort of active. This is something which is happening or being done. The noun, that's a sort of that's a thing which is either doing something or has something done to it. It's sort of it's an object. You know, the adjective, you know, that's something which qualifies the noun. It actually gives you sort of information about it. You know, a tall man rather than just a man. So I know more about the man now because of the adjective. You know, they all play in the sentence different roles, and so you can understand much more about how to use a word if you understand the grammar and how it fits in. Even if I'm learning a new language and I know a little bit about grammar, I will find it much, much easier. So if I go to German and I have to put the verb at the end of the sentence, I will now know how to do that in a sense. And these are the rules. And so it may sound or feel unnatural to me because the grammar is different to the one I know. But once I understand the grammar, I can have the rules and I can follow the rules. Some languages have more rigorous grammar than others, but those rules enable you to more easily understand and build structure to the language, which then starts having lots and lots of different words. And if you didn't have those characterizations of those words, that grammar behind those words, it would just be much, much harder to learn the language because you wouldn't know how to change a word depending on whether, you know, if it's a verb, whether you're talking about something in the past, the present, or the future. You know, the grammar enables everybody to know, even if it's the first time you hear a verb, you know, as soon as you know what that verb means, you know how people are conjugating it, you know, whether they're talking in the past, the present, or the future. And so that's how grammar works in language. And the insight from Wilkinson back in the 80s was that actually, when we build a graph, when we do a visualization, we are going through, we have grammar to these steps. And, you know, if you want, the end result is something we can see. But there are many intermediary steps which are independent of what we see. And that we could change things there and it would change what we see. But this is something where it doesn't affect the other components. And so one of the best examples of this is he distinguishes between, for example, the type of plot you're getting and the axes and how those are displayed on the axes. And what this does immediately is this means that instead of thinking of a bar chart and a pie chart as two different things, you now recognize that the bar chart and the pie chart are one and the same, with the difference being that the pie chart is on a circular axis rather than on your normal Cartesian axis. And so you're changing the way the axes work, and hence you're changing the way the graph looks without necessarily changing the data that's displayed. And so that's what the grammar does. The grammar helps you to recognize, you know, what are the different things you're looking at, and, you know, what are we actually doing? You group them together, and so therefore, in this sort of sense, you're able to put together the different types of graph, whether you're plotting points or lines or whatever of this, you can do the same things. So you could put them on a circular axis as well as your bar chart. And so you're not now needing to just think about all of these as being different. You can just think about them, well, okay, plotting points or plotting lines are different, and you can choose between them, and you could have that on a Cartesian coordinate, or you could have that on a polar coordinate. That's just the coordinate system of your axes, and it can apply to any graph. This, and this is sort of, if you take the grammar of graphics, which I believe you did on a previous week, this is what it does. You know, and I think today, in my understanding is you were learning all about, I think, 8 verbs, was it? How many different verbs were you learning today? Because I think, again,
today we were doing tidyr.
You did tidyr, okay.
Yeah, last time we did dplyr, and the first one was ggplot2.
Yeah.
And this third one is tidyr.
Yeah, and tidyr, I believe, actually, how many verbs does that have? That has about 3 verbs, which are the core sort of piece of language in it. And the point is that all of the Hadley-Wickham structures are structured around these individual verbs that do different things. You know, with dplyr, you're looking at, I think, dplyr is, I think, the 8 verbs, which give you that structure that you understand how you're manipulating. You distinguish between summarizing and transforming. You can do the mean as a summary, or you can do the mean as a transformation. Both of them exist. Both of them make sense. Both of them will give you results. But when you're summarizing, you go from data which is one sort of number of columns to data which has a different number of columns. Whereas when you're transforming, you end up with another column in the same data set. So are you going from one data set to the other, or are you staying in the same data set? That's what matters. Whether you're doing the mean, the median, any of these other statistics, that doesn't matter as much, because you're fundamentally doing the same thing. And you could do that as a summary, or you could do it as a transformation and fit it back into the same data set. This is the insight of the grammar. The insight of the grammar is to understand, do we distinguish between functions because they do something different, you know, like the difference between a t-test and a f-test? Or do we do it because of what they're working on and what they give you? And I think the beauty of distinguishing it and not getting down to the detail of what it's actually doing, what is being tested, is to say that, well, whatever's being tested, I'm going to have to give the data in this sort of way, and I'm going to get a result which will look like this. And so irrespective of what's being tested, it's doing the same function. And that enables you to have the structure that you can then expand the number of tests you could do, and without needing to worry about the fact that you're doing something very different. And this can transform the way we think of statistics. Instead of thinking of needing to learn all the different tests, we can think, we should just learn how tests work. And then if we don't know all the tests, that's okay. We can ask somebody else. Somebody can help us, but we know we'll understand it because we know it's doing the same basic things. We just need to understand how to interpret that particular test afterwards. And this is, I think, a liberation of, well, it's not just a liberation, it's the fact that we're being liberated from having to learn about all the statistics which has been done before we can really feel confident in it. And this is the insight of New Zealand curriculum, that actually, if students know they can always do something, then they can gain confidence in working with data. Whereas if they start being told, you know, here's what regression is, but it only applies under these assumptions, and then the students find, oh, I've got data which doesn't follow the assumptions, I don't know what to do, I need to know more.
David, David, I must say here that this is exactly what we are doing in some of the places, that we say that it's not possible to work with this data because until those assumptions are being fulfilled.
Yes, and that's,
I think what.
well, my father actually, and he's been mentioned once before, Roger Stern. He gives a wonderful talk on this, of coming down to the mountains And there's a reason that this is still taught this way, because actually in the 1960s and 70s, when he was a sort of student and lecturer, this is the state of statistics. You didn't have these unified theories in this way. It's only more recently that statistics has got to this unified state where there is always something you can do. You can look at any data constructively and find something out. It's just, of course, if you have the assumptions satisfied, you can be more accurate. You can be more precise. You can need less data to make statistically significant conclusions. You know, it's very interesting how the word has changed on this. You know, in the past, it was considered the case that if your data didn't satisfy the assumptions, you had to throw it away almost. Now, if the data doesn't satisfy those assumptions, then you might need to collect more of it so you have enough data to make sense. But you don't need to throw it away. It can still form a basis from which you can build. You might not have enough. You might need more data if it doesn't follow those assumptions because the tests are weaker, because you have less information. But if you have enough data, you'll be able to draw out information. And that's the big transformation which has happened.
David, I wish I could have asked you to keep on saying for 1 more hour, 2 more hours, but we now have just about 14 minutes to close the workshop. So I would like to request you to complete your diagram and you to show us this last arrow also.
Yes, okay. I will just take 1 minute then to finish this off and to try and get to this heart of the fact that with what Hadley Wickham did, which you're sort of hearing, is he basically said, okay, we need the same rigor of understanding these different verbs and what really makes sense, what we're doing with statistics for the whole of the analysis process, to go from the actual start, importing data, all the way through to the communication. And we mustn't neglect statistical communication. And this is really insightful from him. It's not enough to do a model. It's not enough to produce a good graph. We as statisticians, we as data scientists, we need to be thinking about how we're communicating the results. And there is not a time in the world where this has been more important because of the amount of misinformation which is getting out and misuse of data, where people are looking at it and then communicating the wrong things because they don't gain the depth of understanding from the data that they are working with. And that is this is sort of where, if you look at this simple diagram, this is a grammar. You can now say, when you take any statistical analysis, you can say, oh, in this part of the analysis, I'm importing. In this part of the analysis, I'm tidying. In this part, I'm transforming. In this part, I'm visualizing. In this part, I'm modeling. And in this part, I'm getting things ready for communication. And the key to that is that in the tidyverse, this is made easier because these represent often the packages you're using. That you are using, you know, if you think of your analysis as a sentence, as a single sentence, you now know what the different words within that sentence mean. And you can give them their grammar, their structure, and you can say what they belong in this. And our analyses should follow this grammar of actually having some importation and leading all the way to ideas of communication. Thank you very much.
Oh, wow. Thank you so much. I think everybody must unmute and clap for David. Thank you very much, David. This was just wonderful. Excellent.
David,
like to
really you have a lot of knowledge and the time is very short to listen you more. You have really good knowledge. Thank you.
Thank you.
And David, if you would unshare your slide, but please stay with us for these few more minutes. And I want to say that, I know how busy you are. I mean, the people here, all the other people, I think they have no idea how busy you are. And in spite of such busy schedule, you've been able to give us such a wonderful talk. This is just very precious for us. I hope that one day, not in too far distant future, I will be able to, and you will be able to do this for us. Invite you to talk about data science and the importance of us statistics people to get to know something about data science, because we now that's the buzzword all over the place, and actually it has so much to do with those mega computers and those all those things which we we don't know anything about really. So maybe one day in the next workshop or the next could you do that for us also a little bit?
I'd be delighted. I would be delighted. However, I should say that while everything I've told you today is sort of, I think, very accepted knowledge and accepted across the community, I think my views on data science, some of those are, this is not something where there is an acceptance. Data science is an evolving idea, and different people are taking it in different directions. So I will try and also represent a bit of that.
What actually I would like you to tell us is that where do we stand? I mean that all these budding statisticians, now that it's all over data science. So what are these my students, my colleagues, younger people who are actually statistics people, where do they stand? That's what I want you to tell us.
I would be delighted to give a talk on that.
Are we still important? Are we still important?
The simple answer to that is yes, but we need to open our minds. We need to be open to learning more.
Exactly. Okay, David, thank you very much. Please do stay with us for this just a short few minutes that we have. Ladies and gentlemen, I'm going to share my screen. And now, if you look at the this schedule, you can see that we have covered a lot, because now we have covered this part also, the highlight of the day, to talk by Dr. David Stern. I have slashed the verbal feedback. I think I'm sure that even if you don't say it, many of you have really enjoyed this talk. But I do want to give Kanwal a chance to speak with you for 2 minutes. But her thing got disconnected. Kanwal, are you back or are you still disconnected?
Yes, ma'am, I'm here.
Okay, then can you open your camera and I will stop the sharing and let people see you. So she is my former student, an excellent student, and she's the rapporteur for this workshop series, and she writes the report, and she also, all these screenshots that we keep taking, she puts them into a very nice video. So Kanwal, please say what you want to say. Kanwal, I want you to open your camera if possible.
Ma'am, it is not possible to open my camera.
Okay, all right.
Thank you so much, Dr. Saleha. Hello, everyone. I would like to congratulate the team TIDYVERSE and all participants for successful completion of PISTAR online training workshop on TIDYVERSE tidyr. It is my pleasure to work as a rapporteur in this online workshop. As the world is becoming more digitalized day by day and learning must continue, so I feel that we are highly in debt to ISOS and PISTAR for organizing such workshops to enhance our technical skills on our studio under the supervision of best instructors. Tidyverse is a very useful package for data analysis to cater for the emerging new needs of data analysis. Through very technical skills gained by learning Tidyverse, we can construct several graphs, transform our data, and utilize it further for data analysis. In the end, I would like to pay my best regards to all of you and the team Tidyverse for their endless efforts, because without them, it would not be possible us to utilize our time in such a positive manner in this pandemic. And I am optimistic that ISOS will organize these type of workshops in the future as well. Thank you so much for being here.
Okay, thank you, Kanwal. Thank you. That was very nice. Ladies and gentlemen, if I can share my screen again, this part is also covered. And now I want to ask Dr. Wasim. Has Dr. Hanif Mia, the president of ISOS, has he been able to join today?
I
Dr.
think,
Wasim?
let me call him. He is not here with us. Let me call
Okay,
him.
he's not here. I think it may not be easy for him to join immediately. In this case, I will request Mr. Iftikhar, Mr. Mohammad Iftikhar, who's the Executive Secretary of ISOS, to please say a few words. Iftikhar, sir, you're
Yes.
here. All right, can we see you, please? Can you open your camera?
My camera is on, but it says that host will block
Well,
the.
all right. People are shy. You know, there's so many people who are shy. All right, you can go ahead.
No, I think Dr. Wasim opened my camera.
All right, good. That's good.
Mr. Khan, I have not restricted your camera. You can.
There is a message. You cannot start your video because the host has stopped it.
But I have allowed you. I have allowed you to start your video.
Actually, I think please do something quickly because all of us are waiting. And actually, Iftikhar Sahib is very annoyed today. Well, he's not really. But you know, Dr. Wasim forgot to send the link to Mr. Iftikhar. He sent it to David Stern. He sent it to all the other people. He did not send it to Iftikhar. So he's quite upset about that. But finally, he did. Okay, please, Iftikhar, camera or no camera, please say what you would like to say.
I am glad to be the part of this third international online workshop on TIDYVERSE tidyr for efficient data tidiness. This is another shining star, including on the PISTAR ISA sky. I am very much grateful to Dr. Saleh, Naghmi, and her team for continuous efforts to promote the research activities of ISAS and PISTAR. The contribution of Dr. Wasim Abbas cannot be ignored. We are expecting the same in future too. Really, it is a fruitful result of Dr. Munir's dream. His soul will be happy to see the extensive work done by Dr. Naghmi and her team. At the end, I am thankful to all the participants, particularly from outside Pakistan. I am sure it will be a fruitful workshop for all of us. Thank you very much.
Okay, thank you very much, Iftikhar Sahib. I'm extremely grateful to you. So, ladies and gentlemen, this is the time to close this workshop. And of course, I cannot close without thanking my team, Dr. Wasim Abbas, already mentioned by Mr. Iftikhar. But I must share with you, ladies and gentlemen, that Mr. Iftikhar himself is also a part of my team. Because you see, there's so much that so much help that we get from him. And Iftikhar Sahab, we are very grateful to you for all the support and all the help that you are always giving us. And I must share with you, ladies and gentlemen, that Dr. Sharqa Hashmi and Ms. Zulaikha Mashkoor, they also work extremely hard with me in order to get these slides right, and to, you know, they're already provided by Garrett Grolement, from whom I learned this in Vancouver. But, you know, we have to make some adjustments to cater for the Pakistani colleagues or for colleagues from other countries. So we do have to rework on these slides. And then, of course, particularly Dr. Sharqa Hashmi she has a very good understanding of our studio, better than me, and probably maybe a little better than Zulaikha also. Kanwal is the one who does this sweet video for us, which we are always looking forward to, and the report. But I also want to thank each and every single one of you, because you see, without you, it would not have been possible. This time, David, you would be interested to note that just about till 2 days back, if David is still here, I wonder. He's here.
I am.
David, there
Yes.
were just
Yep.
two. Okay, there were just 2 participants registered just till 2 days ago. So I was just, I didn't know what to do. I thought maybe we have to postpone it. We have to apologize to those 2 people, 2 persons, and we have to say to them that, okay, if you are unhappy, that then PISTAR or ISOS will return the registration fee also. But then, suddenly we had all these people. Of course, I also was emailing and all that. And now again, we have a good number of people. So I want to say to all of you, my dear colleagues and students from within Pakistan and abroad, that please do help this thing grow. Please do not just join yourself, but please spread the word. I'm sure that you will agree that this last 40 minutes or so that we had with David were actually the really worthwhile. David, I am now thinking that I must start a series in which, in this series only, I think I'm going to do it. I'm going to start reading this book because, of course, when I went to Vancouver, I was also informed of this book on Tidyverse, written by Hadley Wickham and Garrett Grolleman. And now that you have explained all these things so nicely, I'm tempted. I want to do it. I think we should all get together on this Zoom, whoever is interested, and we should start reading this book. What do you have to say to that, David?
It is an excellent book, and I think for anybody, for your budding statisticians who are wanting to understand how to become good statisticians of the future, this is data science written by a statistician, explaining in many ways how to become a good applied statistician using data science by going potentially beyond our traditional statistics. And I think it's a really excellent book. So, so I would strongly recommend the book, and I think I was absolutely wanting people to be aware of that as an open resource. It's freely available, and so I strongly recommend this as a resource for people to refer to.
Okay, thank you very much. And with this, ladies and gentlemen, I thank you all once again. And this is the end of this workshop. Thank you so much.
Thank you all. Thank you, Dr. Naghmi, for this very informative workshop and training. Thank you.
Thank you. I will stay for a few more minutes. I will stay here. Don't, Wasim, do not shut it yet. But people are free to leave. And if anybody would like to stay on. Dr. Amjad, if you would stay on for a half a minute. This thing about the big data being, is it possible to do it with Tidyverse? The huge data that Pakistan Bureau collects and generates, and the Punjab Bureau also.
Dr. Amjad, Dr. Amjad have left.
Okay, all right. Okay. So, Dr. Razia, I'm again extremely grateful to you for your interest. Being a principal of a school, I'm really delighted to have you in this workshop. So could you share with me what you feel? People are free to leave, by the way, but I think I can see Razia here still. So could you share what you feel?
Thank you, ma'am.
हाँ जी, अभी तो ये है कि Najla is also here, so we do speak in English. Because you see, when we have international participants, we would prefer to speak in English. Otherwise, then we can immediately convert to Urdu later. So, Dr. Razia, what is your impression?
Ma'am, I am happy. I have interest in mathematics and stat.
Okay.
I am not student of mathematics and statistics, but I have interest in mathematics and stat.
Okay.
Very good, very impressive.
And where did you learn? Where did you hear about this one? Where did you hear about this workshop? How did you get to know that there is this workshop happening?
Ishtahar Saab, and I have met Ishtahar Saab.
Okay.
I was grouped in
Madam, she's
ISS, SS.
Habib.
Okay.
Uh,
Sorry?
she motivated Dr. Zulaikha Habib is a friend of Dr.
Okay. Okay. Dr. Najla, I want to talk to you right now. Dr. Najla, you're here. I can see your icon.
Yes,
I want to thank you so much. I really want to thank you for offering to do your data next time. You see,
Yeah.
we are also learning as we go along. You see, for us also, this kind of thing is new. And so we are learning. And today I've learned that we cannot accommodate so many data sets in one workshop. So I'm grateful to Raza and I'm grateful to you. And in fact, I think the best would be that even in the next one, we only do one. And then in the next one, we do the other one. Of course, we will not take up any other data before we deal with these three that were given by Thomas and yourself and Raza. So we have two more coming up and we can do Raza's and we can do yours one by one. Do you think that's a good idea?
Yes.
So would you like yours to be happening in the October one, or would you like yours to be happening in the September one?
I prefer September.
Okay, all right. Then I will request Raza to, to wait till October for his one.
Yeah. Prof. Saleha, I have a question, please.
Yes.
You talked about a book and you asked David about his opinion about this book. Which book? Did you publish a book on?
No. I will surely I will share it with you also next time on the screen also. This is a book by written by Hadley Wickham and Garrett Grolleman. Now, Hadley Wickham is the person that Dr. David Stern was referring to again and again during his talk. He is the person who developed TIDYVERSE. And Garrett, yes, he is the person who developed TIDYVERSE, and Garrett Grolleman is a member of his team. So I knew nothing about any of this until I went to Vancouver when they selected me as the educational ambassador for Pakistan. There, when I attended this workshop on TIDYVERSE that was being rendered by Garrett, Garrett is the person who said to us that there is this book. And but I honestly, although it's been 2 years, I have not really read the book. I have read maybe a few pages, but not really read it properly. So that book is about TIDYVERSE. And I will, in the group also, in the WhatsApp group, I will share with you the image. In fact, I can do it right now, but I mean, I'm happy to stay. And if you want, we can try to find it on the Google right now. Dr. Wasim, do you remember the exact title of the book, or Zulaikha or Dr. Sharqa?
Yes, madam, I have the book. I will share with the other people to all the participants.
Can you share it right now on the screen?
I will share when we will share the material, and I will share with the email address.
But do you remember the title of the book? Please tell me. Do you remember?
Yes, I know.
What is it? I'm typing it. Could you tell me?
Let me check.
Sorry?
Let me check.
Okay. All right. I'm writing the names of the authors in the meantime. Hadley Wickham and Garrett Grolleman. Okay. Maybe this will give it also. So let's see. R for Data Science. That's the book. Najla, Dr. Najla. This is the book. This is the book. R for Data Science. All right. And I think the best thing now that we've heard such an exciting and insightful talk by David Stern, I think I'm going to start doing this. All those who are interested, we can read it together. so that we understand all this much better.
Yeah.
So this is the book. That's the answer to your question.
Yeah. Okay.
All right.
Thank you. Yes,
You're
thank you.
welcome. You're most welcome. Any other thing from anybody? Mehnaz, are you still here? I can stop the share now. Mehnaz is not here. Now I think has she left or she's still here? Sharqa, Zulaikha, Najla, Razia, myself, Iftikhar Sahab and Dr. Wasim, Kanwal, and I think that's it. Okay, then thank you very much, everybody. Thanks a lot.
Thank you very much.
Let us stop now.
Allah
Thank you.
Hafiz.
Allah Hafiz.